Hi, welcome to the Corbettmaths Ultimate CA M4 revision video. In this video we're going to go through the M4 topics from the CA GCSE Maths course. So the aim of this video is to spend about 5 or so minutes on each one of those topics to make sure you're familiar with all of those topics. This video is really useful for you if you're revising for M4. I'd highly recommend watching the M3 and M2 videos as well. If you're revising for M8, this video will be useful as well. So this video will go through the M4 topics. So in blue we've got the algebra topics, such as the quadratic formula, algebraic fractions, perpendicular lines and so on. In green we've got the geometry or the shape, space and measure topics, such as circle, theorems, volume over Frustum and so on. In orange we've got the statistics topics, such as stratified sampling and histograms. And in red we've got the number topic, which is apply and bounds. So this is the revision checklist for M4. I'd highly recommend you print this checklist. It's in the description below, so print it and add it to your notes. Beside each one of the topics you've got the video numbers on Corbettmaths, so if you do need a more detailed explanation than this video, you've got much longer videos that you can watch in each one of these topics to make sure that you're really confident in each of them. But the aim of this video is to spend about 5 or so minutes to make sure that you're familiar with each of the topics. So this is the revision checklist. It's in the description below and it's really useful. Also, whenever you're watching this video, you might want to, as I'm going through each topic, you might want to make notes as you're going through it. But also, there's an accompanying booklet of practice questions called the Ultimate CA M4 Revision Question Booklet, where I've put a question or two on each of the topics to make sure that you've got something to practice after you've watched that section of the video. And you can scan the QR code to bring you to this video, or you can scan the QR code for the answers and they'll be useful for you. In this video, I'll also borrow some of the Corbettmaths revision cards, so perhaps whenever I'm going through topics such as circle theorems, I'll be using sections of the Corbettmaths revision cards on circle theorems. So the Corbettmaths revision cards might be very useful for you. For M4, I'd highly recommend the higher set. Also, in terms of revision for M4, rather than leaving your revision to the last minute and trying to cram, it might be a good idea to use a little and often approach. So the 5-a-days, in particular the higher 5-a-days, which are the green books, and the higher plus 5-a-days, which are the blue books, might be useful for you. Okay, so let's get started. So our first topic is Factorising Quadratics, which is video 119 in Corbettmaths. So that's the video number that if you go to corbettmaths.com/contents and you scroll down, that'll be the video for this topic. With Factorising Quadratics, there's two common approaches. One's inspection, which is my preferred technique. Also the split in the middle term. I'll do the first few examples using both approaches, but then as we go through the videos, if there's any more quadratics to factorise, I'll probably use inspection rather than the split in the middle technique, just because it's my default approach. But I will do the first few examples using both techniques. So our first question says to factorise 5x squared plus 13x plus 6. So it's a quadratic and we're going to factorise it. So there's going to be two pairs of brackets like so. And we're trying to factorise something that has a 5x squared at the beginning. That means at the front of both brackets, it won't just be an x and an x like it was often in M3. In this case, it's going to be a 5x and an x because they were multiplied together to give us our 5x squared. If we had something such as 4x squared, it's a bit harder because you're then having to figure out whether it's 4x and x or 2x and 2x. But with this one being 5x squared, that's quite nice. So we've got 5x and an x. Now then, if we were expanding our brackets, we would do 5x times x, which is our 5x squared. Then we would do 5x times this number and then x times that number, and they would add together to give us our 13x's in the middle. And then finally, the number here times the number here will give us 6. So they'll times together to give us this number on the end. So we know that we're looking for two numbers which will times together to be equal to 6 to go at the end of both brackets. Now they could be 1 and 6. They could be 6 and 1. It could be 2 and 3 or 3 and 2. It could also in theory be -1 and -6 and so on, but they wouldn't work for this question because if we had 5x times -1 and then x times -6, when you'd add them together, it wouldn't give you a positive term in the middle. So I know that because this is positive 13x, these are going to be positive numbers here. So we've got 1 and 6. So if we were to put that in the brackets where there's a 1 here and a 6 here, so plus 1 and plus 6, and if we expanded our brackets, we would get 5x times x, which is 5x squared, which is fantastic. We would then have 5x times 6, which is 30x. So that's a bit of a problem because that's quite large. Then we've got 1 times x, which is plus x. And then finally, we've got 1 times 6, which is plus 6. So when we add the terms together in the middle, we would get 5x squared plus 31x plus 6. But we didn't want that. We wanted 5x squared plus 13x plus 6. So let's go back to our 5x and our x, and we want to get 13x in the middle. Now, using the options we've got here, I'm looking at this bottom option here because I know if I use 2, I can do 5x times 2, which is 10x. And then if I put my plus 3 here, that will give me x times 3, which is 3x. And if you add them together, you get 13x. So let's just check it. 5x times x is 5x squared. 5x times 2 is plus 10x. 3 times x is plus 3x. And 3 times 2, which is plus 6. And then if you add the terms in the middle, you get 5x squared plus 13x plus 6. And that's it. And our answer would be 5x plus 3, x plus 2. So the main thing with factorising quadratics is practice. The more often that you factorise quadratics, the better you'll become at it. So you'll get to spot how to put those numbers in really quickly and easily. Okay, so if you want to factorise this using the split in the middle technique, I'd highly recommend you watch that video on Corbettmaths, but the technique is this. First of all, you take the number in front of the x squared, this 5, the coefficient of x squared, the number in front of the x squared, the 5, and you multiply that by the number on the end of the quadratic, the 6. So 5 times 6 is equal to 30, so we do 5 times 6 is equal to 30. Now, we're going to want to find numbers which will times together to be 30, but they will add together to give you the term in the middle, which is 13. So in terms of numbers which will times together to be 30 and add together to be 13, they would be 3 and 10, because 3 times 10 is 30, and 3 plus 10 is 13. So what we're going to do is we're going to split this middle term up, this 13x, into a 3x and a 10x. And if we do that, we get 5x squared. Now we could write plus 10x plus 3x, or we could write plus 3x and plus 10x, and it doesn't actually matter which way around you do that, and I'll show you that in a minute. So let's do plus 10x and then plus 3x, and then we've still got our plus 6 on the end. So we've split this middle term up into a 10x and a 3x. So what we're now going to do is we're going to factorise the first two terms of this expression, and we're going to factorise the second two terms of this expression. So starting off with the first two terms of this expression, we've got 5x squared plus 10x. Now I can see that these two terms have 5x as a common factor. So we'll write 5x, and then we'll do a bracket, and then factorising this by taking out the 5x would leave us with an x to begin with, because 5x squared divided by 5x is just x, and then 10x divided by 5x is plus 2. Now let's factorise the second two terms of this expression. So we've got 3x plus 6. Well, we can divide both of these by 3. So we'll write plus 3 and then open up our brackets. And dividing both of them by 3 will also give us x plus 2. And that's great because we've got the same bracket, this x plus 2, twice. We've got 5x lots of x plus 2, and we've got 3 lots of x plus 2. Now because we've got 5x lots of it and we've got 3 lots of it, altogether that would be 5x plus 3 lots of x plus 2, and that factorizes our 5x squared plus 13x plus 6, because as you can see that's what we got whenever we factorized it using inspection. Okay, so that was one approach. I just want to show you that if you had written it as plus 3x plus 10x, you'll also get the same answer. So this time let's write our 5x squared plus 3x plus 10x, so splitting up the 13x into 3x and 10x plus 6. Now we're going to factorize the first two terms. So we've got our 5x squared and our 3x. Well, the common factor there would just be x, so we'll take x out as a common factor. So dividing both of them by x will give us 5x plus 3. And then our second two terms, we've got 10x plus 6. Well, if we had 10x plus 6, the common factor would be 2, so we'd write plus 2 and then bracket 5x plus 3. And what's great is, again, there we've got the same bracket twice. We've got x lots of 5x plus 3, and we've got 2 lots of 5x plus 3, so altogether that would be x plus 2 lots of 5x plus 3. So as you can see, there are two different approaches to factorise this quadratic. Okay, our next question is to factorise 7x squared plus 20x minus 3. So if I was using inspection, I would put my brackets down like so and put a 7x and an x. Now we know the numbers will times together to be negative 3, so it's going to be 1 and negative 3, or negative 1 and 3, or 3 and negative 1, or negative 3 and 1. So they would be my options, but I know that I want to get 20x whenever I expand. So whenever I do 7x times that number and x times that number, whenever I add them together, they will simplify together to be 20x. Now straight away I know that if I want 20x, it would be really great, a positive 20x. If I put my plus 3 here, I would have 7x times 3, which is 21. Then if I had a minus 1 here, I would then have x times minus 1, well, that'll bring me down to 20x. So that would be it. So my answer would be 7x minus 1 and x plus 3. Alternatively, we could use the split in the middle technique, and I'll just do that in blue ink now. So 7 multiplied by minus 3, so that'll be minus 21. So we want two numbers which will times together to be minus 21, but will add together to be 20. And straight away I'm thinking 21 and minus 1. So 21 times minus 1 would be minus 21, but also minus 1 plus 21 would be 20. So they would be our two options. So we've got our 21x and our x. So let's split up the middle terms. So we could write 7x squared minus x plus 21x minus 3. So we've split up our middle term, our 20x, into a minus x and a 21x. Now let's factorize the first two terms. So if we had 7x squared minus x, we could divide both of those by x. So that would be x bracket 7x, and then taking x out here would be minus 1 whenever we factorize these first two terms. So we get x bracket 7x minus 1. And our second two terms, we can divide both of those by 3. So we would write plus 3 bracket, and dividing both of these by 3 would give us 7x minus 1. And that's great because we've got the same bracket twice. So putting our terms in front, our x plus 3 in a bracket, we would get x plus 3, 7x minus 1, and that's it. Okay, let's have a look at our next question. So our next question is to factorize 4x squared minus 4x minus 3. For the rest of the video, I'm going to stick to the inspection technique. So I'm going to do bracket, 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 bracket. So whenever I factorize this, what I know is that the terms at the beginning of both brackets will multiply together to give us 4x squared. So that could be a 4x and an x, or it could be a 2x and a 2x. And our terms at the end will multiply together to give us negative 3. Well, that's actually pretty good because I know that it's going to be either a 1 and a negative 3 or a negative 1 and 3 in either order. So let's start off with something such as 2x and 2x. I'm just going to use 2x's at the beginning of both brackets. And let's try minus 3 and plus 1. And let's see what we get. So 2x times 2x, so that's 4x squared. Fantastic. Then we've got 2x times 1, well, that's 2x. And then minus 3 times 2x, that's minus 6x. Actually, we've got the answer. Let's expand these brackets and see what we get. So if we expanded these, we would get, so 2x times 2x is 4x squared. 2x times 1 will be plus 2x. Minus 3 times 2x is minus 6x. And then minus 3 times 1, which would be minus 3. And if we simplify these two middle terms, we would get 4x squared minus 4x minus 3. So that's it, we've factorized it. Our next question is to factorize fully 20x squared minus 125y squared. And this is video 120 now, so this is the difference between two squareds. And as you can see here, we've got 20x squared and 125y squared. So we've got the x squared and the y squared, but we don't have square numbers in front of them. We've got 20 and 125. So let's see if we can actually factorize by taking out any numbers to begin with. Now, because we've got 20x squared minus 125y squared, I can see that both of these, the 20 and the 125, have a factor of 5. So let's take 5 out as a common factor, and let's divide both of them by 5. So that would be 4x squared minus 25y squared. Now that's great. Now this is the difference between two squares, which you can see you've got 4x squared, and you get 25y squared, and the 4 and 25 are both square numbers. So that would be, so put our 5 down. And now remember, with the difference between two squares, you put your brackets down, you square root both of them. So square root the 4x squared, so that'd be 2x, and that'll be at the front of both brackets. And square root in 25y squared, that'd be 5y and 5y. And you put one with a plus sign and one with a minus sign, and that's it. Okay, let's have a look at our next topic. So we've looked at factorizing quadratics. Now let's look at solving quadratic equations by using factorization. And that's video 266 in Corbettmaths. So we've been asked to solve 3x squared minus 10x minus 48 equals 0. So what I'm going to do here is I'm going to factorize this left-hand side, just like we would have in M3, but obviously it's just a harder factorization. So let's put our brackets down, bracket, 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 bracket equals 0. And we've got 3x squared, so let's go for 3x and an x. Now we know that two numbers will multiply together to be minus 48, and so that means that one's going to be positive and one's going to be negative, and that whenever we expand our brackets, we're going to get minus 10x in the middle, plus 8 and minus 6. Well, 3x times x is 3x squared. 3x times minus 6 would be minus 18x. X times 8 is plus 8x, fantastic, and then minus 48. So that would be 3x squared minus 10x minus 48. So now we've factorized, let's then solve it. So because we know that these two brackets will multiply together to give us 0, that means that the brackets will be equal to 0. So either this bracket is 0 or this bracket is 0. Now this bracket is quite easy to solve. We know that x will equal 6 there because 6 minus 6 is 0. This bracket, whenever I have a 3x plus 8 equals 0, I tend to write 3x plus 8 equals 0 and then just minus it from both sides. So 3x equals minus 8, and then divide by 3, x equals minus 8 thirds, like so. So there are our two solutions, that either x equals minus 8 thirds or x equals 6. And that's it. So we have solved a harder quadratic equation by factorising. Okay, let's have a look at our next topic. So our next topic is algebraic fractions, and this is video 21 on Corbettmaths. And these algebraic fractions are a bit more complicated than the ones you'd get in M3. And we've been asked to express as a single fraction 2 over 3x plus 1 plus 1 over x minus 1. Now, whenever we're adding together fractions, we want the same denominator. And to do that, what we're going to do is we're going to multiply both the numerator and denominator of the first fraction by the denominator of the second fraction. So we're going to multiply both of these by x minus 1. And for our second fraction, we'll multiply both the numerator and denominator by the denominator of the first fraction. So we'll multiply both of these by 3x plus 1. So whenever we do that, we get, well, we'll write 2, and then we're going to multiply our numerator by the denominator of this fraction. So 2 bracket x minus 1, like so. And then our denominator would be, well, we would have 3x plus 1 in a bracket, and then we're going to put another bracket beside it with x minus 1, like so. So we've multiplied both the numerator and denominator, both by x minus 1. Now we're going to multiply both of these, the numerator and denominator, by 3x plus 1. So when we do that, we get, well, multiplying the numerator by 3x plus 1. Because it was a 1, we could just write 3x plus 1, because we know that we're just multiplying it by 1. And then with our denominator of x minus 1, we're multiplying that by our 3x plus 1. So we've got x minus 1 bracket 3x plus 1. And that's it. And as you notice, we've got the same denominators for these fractions. So we've got 3x plus 1 times x minus 1. And here we've got 3x plus 1 times x minus 1. So now that we've got the same denominators, we can combine our fractions as a single fraction. So we'd have our numerator, so we've got 2 bracket x minus 1, and then we've got our second numerator, so plus, and then 3x plus 1, and then we've got our denominator, which is just 3x plus 1 bracket x minus 1, like so. Now let's simplify our numerator, so let's expand that bracket. So 2 times x is 2x. 2 times minus 1, that's minus 2, and then we've still got our plus 3x plus 1, and our denominator is still 3x plus 1 and x minus 1. And then finally, simplifying our numerator, well, we've got 2x plus 3x, that's going to be 5x. And then we've got minus 2 plus 1, well, minus 2 plus 1 is minus 1, and our denominator was 3x plus 1, x minus 1, like so. And that's it. So we've expressed 2 over 3x plus 1 plus 1 over x minus 1 as a single fraction as 5x minus 1 over 3x plus 1 times x minus 1, like so. Okay, let's have a look at our next topic. So our next topic is called equations, and that's video 111 and 111A on Corbettmaths. So here's our example. It says solve 2 over x minus 3 plus 1 over x minus 4 equals 2. So as you can see, at this left-hand side, we've got two algebraic fractions, and we're going to add them together and combine them as a single fraction. So we'll add them together to write them as a single fraction. So let's do that. So let's multiply both the numerator and denominator of this fraction by x minus 4, and then we'll multiply both the numerator and denominator of this fraction by x minus 3. So doing that would give us 2 bracket x minus 4 over x minus 3 times x minus 4, so multiplying both of these by x minus 4, and then plus, and we're going to multiply both of these by x minus 3. Now because it's a 1, I'm just going to write x minus 3 on the numerator. If there was a number there, I would put it in a bracket and put the number in front, then over, and then I had x minus 4, and then I'm timesing that by x minus 3. And although the brackets are in a different order, remember a times b and b times a is the same thing, that equals 2. Okay, now we're going to combine them as a single fraction. Because they've got the same denominator, I can write my x minus 3, x minus 4. My fraction line went up a bit there. So I can write my x minus 3 and x minus 4. And on the numerator, I have 2 bracket x minus 4 plus, and then we've got our x minus 3. And that equals 2. So I've just written the two fractions as a single fraction, but with the same denominator. Now, what we're going to do is we're going to simplify this numerator. So let's expand the brackets. So 2 times x is 2x, and 2 times minus 4, that's minus 8, plus x minus 3 over x minus 3, x minus 4, like so. And that equals 2. So just expanding these brackets. Now let's simplify the numerator. 2x plus x is 3x. And then we've got minus 8 minus 3, that's minus 11 over x minus 3, x minus 4, and that equals 2. So now we've got 3x minus 11 over x minus 3 times x minus 4 equals 2. Now I don't want these brackets on the denominator here. I want to actually get these off the denominator. So what I'm going to do is multiply both sides of the equation by x minus 3 and x minus 4. So multiplying both sides by x minus 3 and x minus 4. So whenever we do that, well, we're timesing this side by x minus 3 and x minus 4 to get rid of it on the denominator. So we'd just be left with 3x minus 11. And then on the right hand side, well, we're multiplying 2 by x minus 3 and x minus 4. So we would have 2 bracket x minus 3 and x minus 4. So now we're going to multiply this right hand side. So we've got 3x minus 11. And then let's expand these brackets. So let's put our 2 down and put just a big bracket and then expand our brackets. So x times x is x squared. X times minus 4 is minus 4x. Minus 3 times x is minus 3x. And minus 3 times minus 4 is plus 12. Now let's simplify it. So let's simplify these middle terms. So we've got 3x minus 11 equals 2 bracket x squared minus 7x plus 12. Then expand our brackets. So we've got 3x minus 11 equals 2x squared minus 14x plus 24. And then finally, whenever you're solving quadratics, we want it to equal 0. So let's get rid of this 3x and minus 11. So let's minus 3x from both sides. So that would give us minus 11 equals 2x squared minus 17x plus 24. And then we want to get rid of this minus 11. So let's add 11 to both sides. So it'll be 0 equals 2x squared minus 17x plus 35. So we've now got a quadratic which we can hopefully factorize and solve. So when we do that, we get 0 equals, so we factorize our quadratic and we put 2x and x. Now we want two numbers that will multiply together to give us 35. And whenever we expand and add the terms together, will give us minus 17x. So I'm thinking it's going to be a negative and a negative. So let's put a 5 here, so that's 2x times minus 5, which would be minus 10x. And then put a 7 here, so it's minus 7 times x, which is minus 17x. Fantastic. And that's it factorized. Now let's solve it. So we know that whenever two brackets multiply together to give a 0, that they have to be 0. So that means that for our first bracket, we've got 2x minus 7 equals 0. So adding 7 to both sides, 2x equals 7, and dividing by 2, x equals 7 over 2. So x can be equal to 7 over 2 or 3.5 if you prefer decimals. And then our right hand bracket, well, we know then that x equals 5. So our two answers are x equals 7 over 2 or x equals 5, and that's it. So there are two solutions. Okay, so our next topic is the quadratic formula, and that's video 267 on Corbettmaths. Now sometimes we're given a quadratic that can't be factorized, so we solve it by using the quadratic formula. So if you've got a quadratic in the form ax squared plus bx plus c equals 0, where a is the number in front of the x squared, so a is the coefficient of x squared, b is the coefficient of x, the number in front of the x, and c is the number on the end, then you can substitute them into the quadratic formula and it will tell you your solution straight away. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is part of the Corbettmaths revision card. And here's our example. We've been asked to solve 2x squared minus x minus 9 equals 0. Now sometimes in a quadratic formula question it will say solve 2x squared minus x minus 9 equals 0 and give your answers to one or two decimal places, and that's a clue that you're going to be using the quadratic formula. So let's label our a, b and c to begin with. So a equals, b equals and c equals. So a is the number in front of the x squared, so a is going to be equal to 2. B is the number in front of the x, so it says minus x, that means minus 1x, so that means that b is equal to minus 1. And finally, c is the number on the end, which is our minus 9. So we have got a, b and c. Now we're going to substitute those into the quadratic formula. So x equals negative b, well b is minus 1, so we've got negative b. Well, if it's already negative, that's going to make it positive, so that's going to be 1. Plus or minus the square root of b squared, well, minus 1 squared, it's going to be minus 1 squared, minus 4 times a, and I just put it in brackets, so that's 2, times c, which is equal to minus 9, like so. And that's all divisible by 2a, and 2 times a is equal to 4. So we've got x equals 1 plus or minus the square root of minus 1 squared minus 4 times 2 times minus 9, all divided by 4. So now let's simplify what's under the square root sign. So we've got x equals 1 plus or minus the square root of, we've got minus 1 squared. Well, negative 1 times negative 1 is 1, so it's going to be 1. And then we've got subtract, and whenever I work out this 4ac part, I always put my answer in a bracket. So we've got 4 times 2 times minus 9. Now 4 times 2 is equal to 8. Times minus 9 is minus 72. So we've already got our minus sign outside here. So we've got 4 times 2, which is 8, times minus 9, which is minus 72. So that goes there. And then all divided by 4. Next, we've got 1 minus minus 72. That's going to be 1 plus 72, which is 73. So we're going to get x equals 1 plus or minus the square root of 73, all divided by 4. And now, I'm actually just going to move this down here, so I'm just pulling it down here. Now here we're going to have two solutions. We're going to work out 1 plus the square root of 73 divided by 4, and we're going to do 1 minus the square root of 73 divided by 4. So let's write those out separately. So we're going to have 1 plus the square root of 73 divided by 4, and we're going to have or x equals 1 minus the square root of 73 divided by 4. And so let's just work those out in our calculator and see what we get. So we get x equals 2.386 or x equals negative 1.886. And that's it. So we've used the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a to solve a quadratic which couldn't be factorized. Okay, so we've looked at the quadratic formula. Now, sometimes in M4, you're given a question in a wordy context or a wordy situation, and you have to create your own quadratic equation that you need to solve. So let's have a look at a question like that now. So we've been given a context. A field has a width of x meters and a length of 2x plus 1 meters, and the area of the field is 600 meters squared. Find the width and the length of the field. Give your answers to one decimal place. Okay, so first of all in this question, well, we're told a rectangular field, maybe I should have written that in the question, has a width of x meters and a length of 2x plus 1 meters, and the area is 600. So whenever we multiply the width and the length together, we get the area. So let's write that down. X bracket 2x plus 1 equals 600. And then let's expand our brackets. So that would be x times 2x is 2x squared plus x equals 600. And then we like our quadratics to equal 0, so let's take away 600 from both sides. So that would give us 2x squared plus x, and then we take away the 600, it would be minus 600, and then on the right hand side we would have equal to 0. So we're going to solve this quadratic, and we've been told to give our answers to one decimal place. So that's a massive clue that we're not going to be factorizing, because usually whenever you factorize and something with a 2x, you'd either get whole numbers or maybe a 0.5 or something like that. Because we've been told to give our answers to one decimal place, implies we're going to be rounding it. So let's use the quadratic formula here. So let's use our a. Well, a is going to be equal to 2, b is going to be equal to 1, and c is going to be equal to minus 600 or negative 600. And our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So let's substitute our values in. So we've got minus b, well b is 1, so that's going to be x equals minus 1 plus or minus the square root of b squared, well b's 1, 1 squared is 1, minus, and then I like to put this in brackets, 4 multiplied by a, which is 2, multiplied by c, which is minus 600. And then our brackets and big square root sign, all divided by 2a, well 2 times a is 4. Now we've then got x equals minus 1 plus or minus the square root of, and then we've got 1 minus, and let's work out this bracket, 4 times 2 times minus 600 equals minus 4,800, close brackets, and that's all divided by 4. And then let's simplify this. So we've got x equals minus 1 plus or minus square root of. Now we've got 1 minus 4,800, so that's going to be 1 plus 4,800, so it's going to be 4,801, all divided by 4. And remember, with this we've got our two solutions. We've got either minus 1 plus the square root of 4,801 or divided by 4, or minus 1 minus the square root of 4,801 divided by 4. So let's write those out. So x equals minus 1 plus the square root of 4,801 divided by 4, or x equals minus 1 minus the square root of 4,801 divided by 4. And whenever we work both of those out, so typing this one into our calculator, typing in -1 plus the square root of 4,801 divided by 4 gives us 17.0723 and so on. Or this one, if we type this one into the calculator, we get -17.5723 and so on. So we've got our two values for x. Now if we go back up to the question, we're told that x is the width of the field. Now if we go back down here again, we've got one's positive and one's negative. We can't have a negative width of the field. So this will have to be our solution. So x will be equal to 17.0723. So that's going to be the width of our field, and the length is 2x plus 1. So the width is equal to x, which is 17.0723 and so on. And the length was 2x plus 1. So to find the length, we need to multiply this by 2 and add 1. So let's do that. Notice I'm not rounding it yet. So we're going to multiply this by 2 and then plus 1. And that gives us 35.1446 and so on. Now we've been told to give our answers to one decimal place. So answers would be 17.1 meters and 35.1 meters. And they are answers for the width and the length of the field. And that's it. Okay, our next topic. So our next topic is perpendicular lines. So in M3 we looked at parallel lines, and parallel lines were lines that had the same gradient. So they were lines that they would never meet or cross each other, and they would have the same gradient. Now we're going to look at perpendicular lines, and these are lines that meet each other at 90 degrees. They cross each other at a right angle. Now here we've got the Corbettmaths revision card, and as you can see we've got an example here of a pair of perpendicular lines. We've got the line y equals 2x, which is going up in this direction, and then going down in this direction we've got y equals minus a half x plus 1. And as you can see, these two lines meet at 90 degrees, they cross at 90 degrees. Now one thing to notice about their gradients is, well, here we've got 2 and here we've got minus a half. Now the reciprocal of 2 is a half. The negative reciprocal of 2 would be minus a half. So if you know the gradient of one line, if you find the negative reciprocal of it, you'll find the gradient of the other line. So here, if you knew the gradient was equal to 2, if you find the negative reciprocal of it, so take the reciprocal, which is a half, and then make it negative a half, you will find the gradient of the line that's perpendicular to it. Another interesting point is if you multiply the gradients of two perpendicular lines, you will get -1. So if you have 2 times negative a half, well, 2 times negative a half is -1. So the product of the gradients for perpendicular lines is -1. I tend to just use the negative reciprocal. So if you know that the gradient of this line is a negative a half, well, the reciprocal of a half is 2. And then because it was negative, it's now positive. So the gradient of the perpendicular line would be 2. Okay, let's have a look at a question based on that. So here we've got a question that says a line is drawn that is perpendicular to y equals -4x plus 7, and it passes through the point 8, 3. Work out the equation of the line. Now we know that it's perpendicular to y equals -4x plus 7. So it's perpendicular to this line, and this line has a gradient of -4. So if we find the negative reciprocal of -4, you will find the gradient of the line that's perpendicular to it. So we first of all know this gradient was negative, so the gradient for our line is going to be positive, so we know it's going to be positive. And the reciprocal of 4, well, the reciprocal of 4 is equal to a quarter. So we know that the gradient of our perpendicular line would be a quarter, because the negative reciprocal of the gradient that we were given. So we know that the equation of our line will be y equals a quarter x plus c. Now we know that it passes through the point 8, 3, so if this is the x coordinate and that's the y coordinate, we can substitute those into our equation and we can find our c. So we know that our y is equal to 3, so we've got 3 equals a quarter x, so that's a quarter of x, and x is 8, so it's a quarter of 8 plus c. So next we've got 3 equals a quarter of 8 is 2, so we've got 2 plus c. Well, c is going to have to equal 1 here, so we've got what c is. So that's it. So we know that the equation of the line that's perpendicular to y equals -4x plus 7 that passes through the point 8, 3 would have to be y equals a quarter x plus 1. And that's it. Okay, let's have a look at our next topic. Okay, we're now going to look at our geometry, our shape, space and measure topics, and we're going to start off by looking at circle theorems. And these are videos 64 and 65 in Corbettmaths. So here we've got our first circle theorem. So our first circle theorem, and this is part of the Corbettmaths revision card, is the angle in the semicircle is 90 degrees. So if you've got the diameter of the circle and you've got two lines that go from the diameter up to a point on the circle or down, the angle will always be 90 degrees. So here's an example. So if you're given this question and asked to find the value of x, well, here we've got our triangle. We know that's a right angle. So we need to find x. Well, we know that that's 90 degrees. and then we can just use the angles in a triangle to find x. So 90 plus 34, well 90 plus 34 is equal to 124 degrees. And if you take that away from 180, we can see what's left for x. So 180 take away 124 would be 56. So that means that x is 56 degrees. Okay, let's have a look at our next example. Now, one thing to look out for whenever you're doing circle theorem questions is looking for isosceles triangles. So from the centre of the circle to the edge is the radius. So here we've got a radius and a radius, they're two radii. That means they're the same length as each other. So this would have to be an isosceles triangle. So if we know that this angle is equal to 98 degrees, we know this angle x and this angle over here would be the same, so that's x as well. So we can work out what x would be. We could do 180 minus 98, which would be equal to 82. And then if you've done 82 divided by 2, that's equal to 41 degrees. So x here would have to be 41 degrees. So look out for isosceles triangles in circle theorem questions where you've got, particularly whenever radii are involved. Okay, next. Now here again you can see we've got from the centre to the circumference is a radius, so that's a radius, that's a radius, and that's a radius. So here we've got two isosceles triangles. This is an isosceles triangle, and this is also an isosceles triangle. And also another thing to note is the big triangle is a right angle triangle because we've got that diameter as well. So that's a right angle at the top if you add these two angles together. So let's look at our x and y to begin with. So we know that's the radius and that's the radius. That means that y and 55 are the same as each other. Y equals 55. Now I have 55 degrees. Now if y is equal to 55, you've got 55 plus 55, or 55 plus 55 is equal to 110 degrees. So 180 minus 110 is equal to 70 degrees. So that means that x is equal to 70 degrees. And finally, because this is the diameter, we know that x and z are in a straight line. So we know that if we do 180 minus 70, we get x, that's equal to 110 degrees. So z is equal to 110 degrees. And that's it. So it is useful to look out for those isosceles triangles. Okay, next. Okay, so our next circle theorem is that the angle at the circumference is half the angle at the centre. So here we've got our circle, we've got the centre of the circle, and you can see this angle is 120 degrees between the two radii, and the angle at the top here between the two chords would be equal to 60 degrees. So the angle at the circumference is half the angle at the centre. So let's have a look at some examples. Okay, we have our first example. Okay, so we know the angle of the circumference is half the angle at the centre. Well, that means if we double the angle of the circumference, we get the angle at the centre. So if we do 51 multiplied by 2, that's equal to 102 degrees. So that means that x here is equal to 102 degrees. Next, we've got the angle at the centre, and we're trying to find the angle of the circumference. So if we divide the 122 by 2, we'll get the angle of the circumference. So that would be 61. So that means that x equals 61 degrees for this circle. Okay, so the angle at the circumference is half the angle at the centre, or the angle at the centre is double the angle of the circumference. Okay, let's have a look at one more question. So here we've got a circle this time. Here we've got a circle and we've got the angle of the circumference, but we don't actually have the angle at the centre. We've got the angle inside of the shape here. So what we're going to do is we're going to take the 234 away from 360 to find the angle at the bottom. It has to be like this, where you've got the angle at the circumference and the angle at the centre. So if we do 360 subtract 234, we get that's equal to 126 degrees. So that's 126 degrees at the centre. Now the angle of the circumference is half of that, so if we do 126 divided by 2, we get that's equal to 63 degrees. So the angle for x would be 63 degrees. So the next circle theorem is the angles in the same segment from a common chord are equal. So if you look at this chord, this blue line, this dotted blue line, you've got a pair of green lines coming up from either end of that chord, and they're meeting at a point on the circumference of the circle. And likewise, we've got a pair of red lines that are coming off from either end of that chord, meeting at a point at the circumference. That means that this angle and this angle will be equal to each other. Now if you have a look at this example, we've got a common chord here, and we've got all these lines coming off from that chord, either end of the chord, to the circumference. So that means that A, B and 37 are all equal to each other. So if A is equal to 37 degrees, B is equal to 37 degrees as well. And that's it. They're all lines coming off from that same chord. Okay, let's have a look at our next example. So we've got this circle. We've got our 27 degrees, our 88 degrees, and our angle x. And we've been asked to find this angle x. As you can see, we've got this chord at the bottom here. And we've got our lines coming up here and here. And also the lines coming off across here and here. So that means that this 27 will be the same as this angle here. So that means that that angle there is 27 as well. Next thing to notice is we've got two straight lines that cross each other. That means the opposite angles are equal. So if this angle's 88 degrees, that means that that angle's 88 degrees also. They're vertically opposite angles. And finally, you've got this little small triangle here with this x, 88 and 27. That means that those three angles will add together to be 180 degrees. So if we do 88 plus 27, that's equal to 115 degrees. Next, if we do 180 subtract 115 degrees, we get that's equal to 65 degrees. So that means that x is 65 degrees. Now you could have done this question in a slightly different way, where we looked at the 88 and 27 and worked out this missing angle at the bottom, and then looked at the chord and said, well, x is the same as that angle there, and worked it out that way, but that would be 65 as well anyway. Okay, let's have a look at our next circle theorem. So our next circle theorem is, if you've got a cyclic quadrilateral, so that's a quadrilateral where all the corners lie on the circumference of a circle, the opposite angles add up to 180 degrees. So as you can see here, we've got 70 degrees and 110, and we've got 80 and 100. So the opposite angles add up to 180 degrees. Okay, let's have a look at our example. So here you can see we've got a cyclic quadrilateral. This point, this point, this point, and this point are all on the circumference of a circle. That means the opposite angles will add up to 180 degrees. This 114 is outside, but we can actually subtract that from 180 to find the angle inside. So 180 subtract 114 degrees is equal to 66 degrees. So that means this angle in here is 66 degrees. Now we can find our x and our y really quickly and easily. So because the 66 is opposite the x in the cyclic quadrilateral, we know if we take away the 66 away from 180 degrees, we can find out what x is. So 180 subtract 66 is equal to 114 degrees. So that means that x is 114 degrees. Next, our y, well, the opposite angles add up to 180. So if we do 180 subtract 121, that's equal to 59. So we know that y is equal to 59 degrees. So we've worked out what x is and y is by using the fact that the opposite angles in a cyclic quadrilateral always add up to 180 degrees. Okay, next circle theorem. Well, the next circle theorem is if you have the radius and a tangent, they meet at 90 degrees. So here you can see AB is the tangent. So that means that the tangent and the radius meet at 90 degrees. That's a 90 degree angle there. Now here we have got, if this is 154, you can take that away from 180. That would be equal to 26. So that would be 26 degrees in there in a straight line. Next, we've got a triangle. We've got 90 degrees and 26 degrees. If we add those together, we get 116 degrees. So 180 minus 116 degrees equals 64 degrees. So that's 64 degrees there. And then finally, we have a straight line here. So if we do 180 minus 64, we get that's equal to 116 degrees. So that means that x equals 116 degrees, and that's it. So the radius and the tangent will meet at 90 degrees. Our next circle theorem, it's got a name that I always remember, that's the alternate segment theorem. And that is if you have a tangent, the angle between the tangent and a chord equals the size of the angle opposite it inside the triangle. So this 70 is the same as the angle opposite it in the triangle, and the 60 is equal to the 60, the angle opposite it inside the triangle. And that's called alternate segment theorem. So let's have a look at our example. So here we've got our tangent, and the angle between the tangent and the chord is 55. So that 55 will be equal to the angle opposite it. So x is equal to 55 degrees. And here we've got our y, that's equal to the angle opposite it. So y would be 60 degrees. And that's it. Now what's interesting is if you go to the videos and worksheets section in Corbettmaths, there's a video showing you the proof of this. So if you want to see why they're equal to each other, have a look at Corbettmaths and you can see me explaining why. Okay, next. Okay, two more interesting circle theorems are, if you've got a point, the two tangents from that point to the circle will be the same length. So as you can see here is this point C, and you can draw two tangents to the circle that meet at D and E, and the lengths of CD and CE will be equal to each other. And then finally, if you've got a chord, the radius that cuts that chord in half will meet the chord at 90 degrees, like so. Okay, so that was circle theorems. We're now going to look at volume and surface area. Now in M4 we're asked to solve more complex problems, for example involving frustums. Now whenever we look at frustums, that will often involve cones and pyramids. So the volume of a cone is found by a third pi r squared h, which is a third the area of the base times the height. And that also applies to pyramids. So if you are given a pyramid, the volume of that pyramid will be a third times the area of the base times its height. Okay, so here we've got a cone, and let's practice working out the volume of this cone because it would be useful for finding the volume of things such as frustrums. So here we've got a cone, and you can see we've got the radius of the base is equal to 20, and we've got the height is equal to 21. So its volume is equal to a third times pi times by the radius of the base, that's times by 20 squared, times by its height, 21. So when we work that out, we get the volume would be equal to 2,800 pi, or if we want to write it as a decimal, 8,796.46 centimeters cubed. Now that formula is given to you at the front of your M4 paper. This has been snipped from the Corbettmaths revision card. So the volume of a cone is equal to a third pi r squared h, or if it's a pyramid, so volume is equal to a third the area of the base, the pi r squared is the base, times the height. And that'll be very useful for whenever you're finding the volume of a frustum, and I'll talk about that in a moment. Also, talking about volumes of pyramids, here's a pyramid, and if you've been given a pyramid and you're asked to find the volume of it, again the volume is equal to a third the area of the base times the height. So it's going to be the volume is equal to a third times the area of the base, well, that's going to be 9 times 6, so 9 times 6 is equal to 54, so times 54, times its perpendicular height, so that's going to be from the base straight up to the top, which is 7 centimeters. And whenever we work that out, we get that's equal to 126 centimeters cubed. And as I said, the volume of a cone and a pyramid will be very useful for finding the volume of a frustum. Very useful, or essential to it. Okay, next. We've been asked to find the volume of a frustum. And a frustum sounds complicated, but it's just a cone or a pyramid with the top chopped off. So here we've got, this is video 360A in Corbettmaths, and it says, shown as a frustum of a cone, so as you can see the top's chopped off, that had a perpendicular height of 20 centimeters. So it did go up to a top point, just say there, and down again, and it did have a height of 20 centimeters in total. Now the height of this part is 10, so it would have had another 10 centimeters to have a total height of 20 centimeters. And we've been asked to find the volume of the frustum, so that's the bit that's left, this part here. So to do that, what we're going to do is we're going to work out the volume of the cone to begin with, so the whole big cone. We'll then work out the volume of the cone that's been chopped off, and then take them away and see what's left. So let's do the volume of the big cone. So the volume is equal to a third times pi times the radius. So for the big cone, the radius is 8, so 8 squared, times its height, and we've been told its height was 20 centimeters. Okay, and whenever we work that out, we can either get 1,280 over 3 pi. You'll learn about working exactly with pi in M7, I believe. Alternatively, you can write it as a decimal number as 1,340.412866 and so on centimeters cubed. That's the volume of the whole big cone to begin with. Now the top was chopped off, and that is a smaller cone. It's similar to the large cone. You'll learn about similarity later, which means enlargement, but so we'll just work out the volume of this. So working out the volume of this smaller cone, it's got a volume of a third times pi times the radius 4 squared times its height 10. And whenever we work that out, we get, and that's equal to 160 over 3 pi, or alternatively 167.5516082 centimeters cubed. And then finally, to work out the volume of the frustum, well, we're going to take that away. So we're going to do 1,340.412.866, take away the 167.5516082, and when we subtract them, we get 1,172.86 centimeters cubed, and I've rounded that to 2 decimal places. So if you ask to find the volume of a frustum, you just work out the volume of whatever shape there was to begin with, whether it's a big cone or a big pyramid. You work out the volume of what's been chopped off, and then you take them away, and that'll tell you the volume of what's left. Okay, and our next topic now, in M4 it doesn't actually specify if it's just the volume of frustrums or the surface area of frustrums. So if I wanted to work out the surface area of this cone, it would be pi times the radius, which is 6, times the slant height, which is 11, and that would be equal to 66 pi, or 207.345 and so on centimeters squared. But also remember, there's the base of the cone. Then we'd need to work out the area of the base, which would be pi times 6 squared. And whenever we do pi times 6 squared, we get 36 pi, or 113.0973 and so on. And when we add those two together, we get 320.44 to 2 decimal places centimeters squared. So to find the surface area of a cone, you find the surface area of the curved surface, so the top part of the cone here, which would be found by pi RL, so pi times the radius times this diagonal length, and that gives you the curved surface area of the top. But also remember to add on the area of the base, so that's circle, and that will give you the total surface area of a cone. If you were then asked to find the surface area of a frustum, you might find that the top part's being chopped off, so you might want to then use that pi RL to work out the curved surface area, the bit that's been chopped off, to see what's left. And then remember, you'd have two circles, so that information might be useful for you as well. Okay, so now let's look at our statistics topics, and our first statistics topic is called stratified sampling. Stratified sampling is really useful for whenever you want to find a suitable sample for groups where there's not the same number in each group. So for instance, here we've got year 7, there's 120 year 7s, there's only 80 year 8s, and there's 100 year 9s. Well, it wouldn't be fair to take a sample of the same number of year 7s, 8s and 9s, because there's a lot more year 7s than year 8s. So you can use a stratified sample that keeps the sample in the same proportions as the population, or close to it. So the formula for stratified sampling is the number in the category divided by the total times by the sample size. And the question says Miss Holland wants to take a stratified sample of 15 students, and it says how many year 7s should she survey. So it's a bit of a tongue twister. And so let's start off with year 7s. So we want to find out how many year 7s she want to survey. So the number in that category, well, there's 120 year 7s. Divided by the total, well, let's work out how many students are in total here. So 120 plus 80 plus 100 is equal to 300. So we're going to divide that by 300, and then we're going to times by the sample size, which is 15. So whenever we do 120 divided by 300 times by 15, we get that's equal to 6. So Miss Holland should sample 6 year 7s. If you wanted to find out how many year 8s you would sample, you would do 80 divided by 300 times by 15. And for year 9s, you would do 100 divided by 300 times by 15, and then that would be it. Now sometimes with stratified sampling you might get decimal numbers, and then you would need to round them. Just make sure that whenever you've rounded them that you do get the total number of 15. So if you've rounded 2 up, you might find that that would put you to 16 students, so you might need to just round one of them up and so on. Okay, let's have a look at our next topic. Our next topic is histograms. So a histogram is a way of representing group data, and here we've got our group data, and it's a way of representing it and in a fair way whenever you've got categories that have got different sizes. So as you can see here, we've got time 0 to 2, 2 to 4, 4 to 6, 6 to 10, 10 to 14 and 14 to 20. So as you can see here, we've got groups that are quite small. So the first group's only got a width, a class width of 2 seconds. It's only 2 seconds wide from 0 to 2. But the last group goes from 14 to 20, so it's actually got a width of 6. So it wouldn't be fair to draw a bar chart because some of the categories are much bigger or much wider than the other categories. So you draw a thing called a histogram. And the histogram looks at the frequency density. And the frequency density is found by doing the frequency divided by the class width. Now just before I go on, histograms is a very important topic. So if you go to videos 157 to 159 in Corbettmaths, you'll see me talk about histograms in great detail. And if you're studying for M4, I'd highly recommend you do that. So what we're going to do is we're going to start off by drawing a histogram for this grouped frequency table. So if we want to draw a histogram, we're going to work out a thing called frequency density. So let's put a column on for frequency density. So I'm going to write FD, standing for frequency density here. So we've added on a column for FD, or frequency density. Now what we're going to do is we're going to work out the frequency density for each one of these groups or classes. So from 0 to 2 seconds, well, that's got a class width of 2. It's 2 wide. It's got a frequency of 10. So if we do 10 divided by 2, so the frequency divided by the class width, 10 divided by 2, so 10 divided by 2, that gives us a frequency density of 5. So this category has a frequency density of 5. Our next category, well, it's got a frequency of 13, and it's got a class width of 2. It's 2 wide, going from 4 to 2. 4 take away 2 is 2. So we're going to do 13 divided by 2. So 13 divided by 2 is equal to 6.5. Our next group, well, again, its frequency is 18, and its class width, well, it goes from 4 to 6, so its class width again is 2. So we're going to do 18 divided by 2, and 18 divided by 2 is 9. Our next group, it's going from 6 to 10, so it's got a class width of 4 because it's 4 wide, and it's got a frequency of 16, so we're going to do 16 divided by 4 because we do the frequency divided by the class width. That's 4. Next, the next category has got a frequency of 8, and we're going to divide that by the class width, where that's equal to 4 because it's 4 wide. So 8 divided by 4 is 2. And finally, our last group has got a class width of 6 because it goes from 14 to 20. That's 6 wide. And its frequency 6, so we're going to do 6 divided by 6, which is 1. So we've got our frequency densities. Now what we're going to do is we're going to draw a histogram. So we're going to draw bars for each of our groups. So our first group is from 0 to 2. So we're going to do a bar going from 0 to 2 and having a frequency density of 5. So it's going to go up to 5. So with a ruler and a pencil, you'd go draw a line from 5 across. With a ruler and a pencil, you draw down and you draw your bar like so. So that is your bar going from 0 to 2 and with a frequency density of 5. Our next bar, well, from 2 to 4, it's going to go up to 6.5. So from 2 to 4, well, we actually need to make our bar a little bit higher. So we're going to go now up to 6.5. So it's going to be halfway between 6 and 7. So that's there. We're going to go across to 4 and then down. Our next bar, well, from 4 to 6 goes up to 9. So from 4 to 6, we'll go up to 9. So again, we need to make that bar a bit higher. We're going to go up to 9 now, across and down. So we've done from 0 to 2 up to 5. We've done from 2 to 4 up to 6.5. And we've done from 4 to 6 up to 9. Now we're going to do from 6 to 10 and with a frequency density of 4. So from 6, which is here, to 10, we're going to have a bar that goes up to 4. So we'll draw across to 10 and then we're going to go down like so. So that bar from 6 to 10 has got a height of 4. Next, we're going to go from 10 to 14, and that's got a height of 2. So from 10 to 14, we're going to go across from 2 and down. And finally, the last group goes from 14 to 20. So we're going to go from 14 to 20, and it's got a height of 1. So we're going to go make sure its height's 1, and we're going to go down like so. And that's it. We've drawn our histogram. So we've drawn our histogram for our group frequency table. Now sometimes we're given a histogram and we might need to find out the frequency. Now if we go back, frequency density was equal to frequency divided by class width. If we wanted to make frequency the subject, we would multiply both sides by class width. So that would give us the frequency density times class width is equal to frequency. So the frequency is equal to the frequency density times the class width. So in other words, if you multiply the height of each bar, the frequency density, by its class width, how wide it is, you will find the frequency. So let's complete this grouped frequency table. So we've got our categories, 0 to 40. So as you can see, our first bar went from 0 to 40. Now, if we look vertically, we're going from 0 up to 1. There's 10 little squares. That means that each square is 0.1. So this bar has a height of 0.1, a frequency density of 0.1. And it's got a class width from 0 to 40 of 40. Well, if we do the frequency density, 0.1 times by 40, that's equal to 4. So that means the frequency for this bar is equal to 4. So as you can see here, the frequency would be 4. Next, our next bar. Our next bar goes from 40 to 60, and its frequency density, well, it goes up to 2.4. So the frequency density is 2.4. So we're going to do 2.4 multiplied by the class width, which is, well, from 40 to 60 is 20. So multiplied by 20 is equal to 48. So that means that this category from 40 to 60 has a frequency of 48. There was 48 people. And then our next category from 70 to 80, well, the class width is 10. Its frequency density, well, it goes up to 3.9. So we're going to do 3.9 times 10. So 3.9 times 10 is 39. So it would have a frequency of 39. So to draw a histogram, we use the formula frequency density is frequency divided by class width. So if you've been given a histogram and you want to find the frequencies, well, we would do frequency density times class width. Okay, let's have a look at a typical histograms question now. So the histogram below shows information about the number of hours flown by some pilots. And we're told that 45 pilots flew for more than 400 hours. So we know that between 400 and 450 hours, there's 45 pilots in here. Okay, so our first question says to estimate how many pilots flew for under 100 hours. So if you have a look at our histogram, the first category goes from 0 to 200. So that's why the question says estimate, because whenever we had this group frequency table, it would have said 0 to 200 and it would have the frequency. So because it's group frequency, we don't actually know how many were between 0 and 100 or 100 and 200. So this is going to be an estimate. So if we have a look at this bar, let's work out the frequency for this bar. It's got a frequency density of 3.5 and the class width is 200. It goes from 0 to 200. So if we do 3.5 multiplied by 200, that would tell us the frequency, and that's equal to 700. So that means there's 700 pilots in here. Now, under 100 hours, well, that would be half of the pilots. Well, our estimate, our guess will be it's half of the pilots. So we're going to do 700 divided by 2, and that's equal to 350. So that's our educated guess to how many pilots have flew under 100 hours. We do know the 700 that flew between 0 and 200 hours, and our estimate is that half of those, 350, have flew for under 100. Okay, our next question. Our next question says, what fraction of pilots flew between 200 and 400 hours? So we want to work out the fraction of pilots, so we're going to need to know how many pilots there are altogether. So let's get rid of that dotted line to begin with. And we know there's 700 in this bar. We've been told there's 45 in this bar because 50 multiplied by 0.9 is 45. So we know there's 45 in there. Let's work out how many pilots are in this bar and this bar. So for this bar here, it has a frequency density of 4.7. So a frequency density of 4.7 multiplied by a class width of 100 would be equal to 470. So there's 470 pilots in here. And this bar has a height frequency density of 2.5. And again, the class width is 100. 2.5 times 100 is 250. So we know there's 700 pilots between 0 and 200, 470 pilots between 200 and 300, 250 pilots between 300 and 400, and 45 pilots between 400 and 450. We've been asked to find out what fraction of pilots flew between 200 and 400. So that's going to be altogether. So 470 plus 250, that's 720 out of all the pilots altogether. So it's going to be 700 plus 470 plus 250 plus 45. That's equal to 1,465. And if I type that into my calculator, it'll simplify nicely for me to 144 over 293. Okay, our next question. Okay, let's have a look at our next question. So our next question says, the histogram shows the heights of 2,400 trees. So we've got their heights in centimetres from 0 all the way up to 250. And we've been asked to find an estimate for the mean height. We've been asked to find an estimate for the median height. So if I was working this out, the first thing I'd want to know is the frequencies. So we've got the frequency densities of 8, 16, 20, and 5. And I would want to work out the frequencies for each one of those bars. So we've got here this bar 75, this bar would be 125, and yeah. Okay, so for the frequency for this bar from 0 to 75, well, I would do the frequency density 8 times the class width, which is 75. So it has a frequency of 600. Next, from 75 up to 125, it's got a class width of 50 times by 16 is 800. Next, from 125 to 150, that's a class width of 25 times by 20 is equal to 500. And finally, from 150 up to 250, that's 100 as a class width, times by 5 is equal to 500. And let's just add our frequencies up. 600 plus 800 plus 500 plus 500 is equal to 2,400, which we're told in the question, which is fantastic. So the question asks us to work out an estimate of the mean height and an estimate of the median height. Let's start off with the mean height. Now I'm actually just going to draw a frequency table like so, and our frequencies were 600, 800, 500, and 500. And we've got our heights as 0 to 75, 75 to 125, 125 to 150, and 150 up to 250. Now we want to find an estimate of the mean. So remember, that's where we add on our fx column, and we do the midpoint times the frequency, midpoint times the frequency, and so on. So the midpoint for our first category from 0 to 75, well, that's going to be 37.5. So we're going to do 37.5 times 600, and that's equal to 22,500. Next, we'll do the midpoint. Well, the midpoint of 75 and 125 is 100. Times that by the frequency is 80,000. Next, we'll do the midpoint of 125 and 150, and that's 137.5. Remember, we can find the midpoint by just adding the numbers and dividing by 2. Times by 500 is equal to 68,750. And finally, we're going to do the midpoint of those numbers, which is 200, times by 500, which is equal to 100,000. Next, to find the estimated mean, we add up our fx column, so we find the grand total. And when we do that, we get 271,250. And then we divide that by the total frequency, but we're told in the question that's 2,400. So we could add up the frequencies, or we could just use the fact that we're told it in the question. So when we divide 271,225 by 2,400, the grand total divided by how many there are, that would tell us our estimate for the mean height. Remember, they're estimates because we're using the midpoints and we don't actually know the actual values. That's equal to 113.02 centimeters. And that's it. So that's our estimate of the mean. So that's the 2 decimal places, and that's it. Okay, next we were asked then to find an estimate of the median. Okay, so our next question says, find an estimate of the median height. So if we go back to our histogram and we look at each bar, its area represents its frequency, because the frequency density, the height of the rectangle, multiplied by the Klatt's width, the width of the rectangle, that gives us our frequency, or the area of the rectangle. So that means that the frequency is represented by the area of the rectangle. So that means that we can find the vertical line that we draw down, so that half the area of the histograms on the left and half the area of the histograms on the right, that means that we can read off and find out what the median would be. So let's find the area of this histogram. Now I could count the little tiny squares if I wanted to, but I'm actually going to count the bigger blocks, because I can actually see in this question that there's lots of these whole blocks, and each of the bars sort of is split up into these larger blocks, apart from obviously this one where I've then got half blocks. So if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, so there's 48 big blocks. So if I can find out where the halfway, the 24th block is, and divide it, so there's 24 blocks on the left and 24 blocks on the right, we can find out where the median would be. So let's find out where the 24th block would be. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 blocks in that one. So we need number 12. We've got 1, 2, 3, 4, 5, 6, 7, 8. Well, 12 plus 8 is 20. Now we need another 4. But we've got, if we look across here, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we actually only need 4 blocks. That's half of those. So if we took our ruler and a pencil and we went halfway down here, that would mean that we would have 24 blocks worth on the left and 24 blocks worth on the right. And that value would be, well, it's in between 100 and 125 and exactly in the middle. So the median would be 112.5 centimeters. And that's it. So that's one way of finding the median. Now you may have been able to guess that that's not actually the approach that I use whenever I work out the median, just because I don't like counting the little blocks and trying to figure out where that line is. I use an approach called linear interpolation. So it's video 52 in Corbettmaths, and the formula for it is the lower bound plus number into category divided by number in category times Klatt's width. It sounds quite complicated, but it's not really. So it's lower bound plus number into category divided by number in category times Klatt's width. And let me explain what I mean by that. So we're looking for the median value. So if there's 2,400, we divide that by 2, because remember for group data, it's just an estimate anyway. So we can do 2,400 divided by 2 is equal to the 1,200 value. And if I was looking for the 1,200 value, I would look at my frequency table and I would say, well, the 1,200 value is not in the first category because there's only 600 in there. If I look at the next category, there's 800 in there. So altogether, if I work out the cumulative frequency, there's 1,400 trees altogether. So the 1,200th tree is in this category here. So we're going to look at this category and we're going to say what's its lower bound, that's 75, plus the number into the category. We're looking for the 1,200th tree. So we've gone 600, we need to go another 600, so we need to go another 600 into this category. So we'll write 600, it's 600 into the category, divided by the number in the category, well that's 800, and then times by the Klatt's width. The Klatt's width is 50. So if we do 75 plus 600 over 800 times 50, we should get that median that we got before. And the answer is 112.5 centimeters, which is the same as before. The reason I like that formula is you can then work out the lower quartile, upper quartile, interquartile range really quickly and easily from histograms. And the formula is not actually that complicated. Okay, let's have a look at our last histogram question. This is the hardest histogram question we've got here. And it says 24 cars traveled faster than 40 miles an hour. So we know that 24 cars traveled faster than 40 miles an hour. And it says estimate the number of cars traveling between 25 and 35 miles per hour. So here we've got our histogram and we've got the frequency density going up vertically with no numbers, that's not going to be very helpful, and we've got our speed going across horizontally. And we've been told that 24 cars, so we know there's 24 cars in this bar here. And it says, or work out an estimate for the total number of cars traveling between 25 and 35 miles per hour. So we want to work out an estimate for how many cars would be in here. Now, first of all, what makes this question a lot harder than the previous ones is we don't know the frequency densities. So there's two different approaches you could use for this question. The first one, because we know that 24 cars travel more than 40 miles per hour, we know that the frequency for this bar is 24. So if you do 24, the frequency, divided by the Clark's width, we can get the frequency density. 24 divided by 10 is 2.4. So we know that the frequency density there would be 2.4. So we know the frequency density is 2.4. Now we can figure out our scale. So we've got 2.4s here. Well, there's 1, 2, 3 lines going up to that. So if we divide that by 3, that's 0.8. So 0.8, 1.6, 2.4, 3.2, 4, 4.8, and 5.6. So now that we've got our scale for our frequency density, we can now work out our estimate for how many cars are traveling between 25 and 35 miles per hour. So let's work out the frequency for this 20 to 30. So we would do the Clark's width, which is 10 times 4. So that means there's 40 altogether in this bar. So that means that if we divided it by 2, there should be 20 in here. And likewise for this bar, this one going from 30 to 40 miles per hour. So we would do 10 times 5.6, which is 56. And if we divided that by 2, there'd be 28. And 20 plus 28 is equal to 20 plus 28 is equal to 48 cars. So that's our estimate for how many cars should be traveling between 25 and 35 miles per hour. So that's one approach. Now that question was quite nice because the information we were told is there's 24 cars traveling more than 40 miles per hour. So we were told the frequency for one of the bars. Sometimes in the question you might be given sort of, so many cars are traveling more than 35 miles per hour. It's a bit more complicated. Or another approach is to consider the frequency and to look at the area of that bar that represents that frequency. So as you can see, there's 1, 2, 3, 4, 5, 6 smaller squares inside that bar, and that represents 24 cars traveling more than 40. So if you do 24 divided by 6, you'll find that there's 4 cars in each one of these. 4, 4, 4, 4, 4, 4. Each one of those squares represents 4 cars. So if you wanted to find an estimate for how many cars were traveling between 25 and 35, we can consider how many of those squares are in that region. So as you can see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could do 12 times 4 is equal to 48. And that's the same estimate again. So that is another approach. Alternatively, sometimes you can find that it doesn't work out even as nicely as that because it might not be whole number of blocks. So what you could do is actually say, well, altogether there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares going across. And there's 5, 10, 15 of those. So there's 150 little squares. So 150 squares equals 24 cars. You could then divide 150 by 24 and say, well, 150 divided by 24 is equal to 6.25. So 6.25 squares equals 1 car. Then you could look at the 25 to 35 region and see how many little squares there are in those. So as you can see, we've got 5, 10, 15, 20, 25 times 5. So there's 125 little squares there. And from 30 to 35, there's 5, 10, 15, 20, 25, 30, 35 times 5 is equal to 175. So altogether there would be 125 plus 175, which is 300 squares. And if we divide that by 6.25, we can see how many cars it would be. So 300 divided by 6.25 is also equal to 48 cars. And that's it. Okay, let's have a look at our last topic. So our last topic is applying bounds, and that's video 184 in Corbettmaths. So we've looked at in M3 applying some bounds already, but we're going to look at some harder situations now. So we've got the lengths of time taken by 4 people to complete a puzzle are listed below. And it says each time is given to 1 decimal place. So the 4 people have taken seconds to 1 decimal place, 8.4 seconds to 1 decimal place, 35.5 seconds to 1 decimal place, and 19.8 seconds to 1 decimal place. And we've been asked to work out the greatest possible range. So remember, the range is equal to the largest subtract the smallest. So the largest subtract the smallest. So here, our largest value would be this one, 35.5, and our smallest value would be 8.4. But each of these times have been rounded to one decimal place. Okay, so let's find the upper bound and lower bound for these values. Now, before we do that, I'd highly recommend you watch the M3 video just to make sure that you're confident with finding the upper and lower bounds. So the upper bound, so this number's been rounded, this 8.4 has been rounded to one decimal place. So the upper bound would be 8.45 seconds, because it could go up to 8.45 seconds, but not including. And the lower bound would be, well, it could go down as far as 8.35 seconds, because that's the lowest possible value that would round up to 8.4 seconds. Likewise, for 35.5, the upper bound would be 35.55 seconds, and the lower bound would be equal to 35.45 seconds. So we've found the upper bound and lower bound for each of those values, and we've chose those ones because we're looking at the range, which is the largest subtract the smallest. Now we want to work out the greatest possible range. Now that's going to be found by using the greatest possible value for the largest value, and it's going to be found by using the smallest possible value for the smallest value, because when we take them away we get the biggest possible answer. So we're going to want to use the upper bound for the largest value, and we're going to want to use the lower bound for the smallest value, because when we take them away we'll get the biggest possible answer. So we're going to do 35.55 seconds, and we're going to take away 8.35 seconds, and whenever you do that you get 27.2 seconds. Now you can actually try the other values to see if you can get a bigger answer. You could try 35.45 and 8.45 and take those away and so on, but you're going to find that that's the biggest possible answer. You want to find that you want to make the biggest difference between them, so you're going to want to use the biggest value and the smallest value, so when you take them away you get the greatest possible range. If they wanted the smallest possible range, you'd want them to be as close together as possible, so you use the lower bound for the largest value and the upper bound for the lower value, so that they're closer together, and they'll give you the smallest possible range. Okay, next question says Natalie runs 100 meters to the nearest 10 meters. So it's 100 meters to the nearest 10 meters. That means it could be the lower bound would be 95 meters and the upper bound would be equal to 105 meters. They're the upper and lower bounds for how far she's ran. And it takes her 14 seconds to the nearest second. So the lower bound would be, so she could do it in 13.5 seconds, or the upper bound, the greatest possible amount of time it would take, would be 14.5 seconds. They're the lower bound and upper bound for 14 seconds to the nearest second. So the question says to work out the greatest possible speed. So we're working out speed. So the speed is found by the distance divided by the time. Now we've been asked to find her greatest possible speed. So to do that, what you want to do is you want to run the largest distance in the smallest possible time, because the largest distance in the smallest possible time will give you the greatest speed. So the greatest possible distance would be 105 meters. That's the greatest possible distance she could run. And the smallest amount of time would be 13.5 seconds, because if she ran a large distance in a smaller amount of time, that means she's running even faster. So if you've done 105, the upper bound, divided by the lower bound, that's going to give you the greatest possible speed. So 105 divided by 13.5 would be equal to 7.778 meters per second to 3 decimal places. So that would be her greatest possible speed. If you wanted to find her slowest possible speed, you should do the smallest distance in the greatest amount of time, and that would mean she's traveling slower, and so on. Okay, let's have a look at one last question. Okay, our last question on applying bounds. We've been told that w is equal to the square root of c divided by x minus 1. And we've been told that c is equal to 9.5 rounded to 1 decimal place. That means the lower bound for c would be equal to 9.45 and the upper bound for c would be equal to 9.55. And we've been told that x is equal to 4.81 to 2 decimal places. So the lower bound for x would be equal to 4.805 and the upper bound for x would be equal to 4.815. And we've been asked to find the lower bound of w. So if we want to find the lowest possible value for w, we want to divide the lowest possible value for the square root of c by the biggest possible value. Whenever you want to find the lowest possible something, you want to divide the smallest amount by the biggest amount. That'll give you the smallest answer. So whenever we do this lower bound for c, well, this lower bound for c would be the square root of 9.45, because that will be smaller than the square root of 9.55. And then we're going to divide that by x. Well, we want to divide it by the biggest possible thing to give us a small answer. So we're going to do 4.815 minus 1, because the upper bound 4.815 and then we've taken away 1. And when we do that, we get 0.805789 and so on. Okay, so that's the lower bound for W. So whenever you want to find the lowest possible answer, you would want to do the lowest divided by the biggest. And if you wanted to find the upper bound for W, you would want to do the largest divided by the smallest. So you'd use the upper bound for C and you'd use the lower bound for X. And that's it. So I really hope you found this video useful. In this video we've spent about 5 or so minutes, maybe for histograms a bit more than 5 minutes, but in this video I've spent around 5 or so minutes on each one of these topics. I really hope you found it useful. This revision checklist can be found in the description below, so remember to print it, add it to your notes, stick it on your wall, whatever, as long as you go through these CCEA M4 topics and make sure you're really confident with them. Also, if you need a more detailed explanation, you've got all the video numbers there, and you can go to Corbettmaths and watch those. Also, as well as this video, remember there's that bumper pack of questions, so as you're going through the video it might have been useful to try some questions in each of them. If you haven't done that, feel free to click on that now, and you'll have some questions in every single topic in the video, and there's the answers for them as well. Also in this video we've used quite a lot of the Corbettmaths revision cards. The higher revision cards will be really useful for you if you're studying for M4. And in terms of the 5-a-days, that little and often approach to study can be really useful. It can really help you retain information that you've learnt in class. For M4, I'd highly recommend looking at the green higher books and the blue higher plus books. So they'll be really useful in terms of using a little and often approach. Invest in 5 or 10 minutes every single day will really make a massive difference to your results. I really hope you find this video useful. This has been the ultimate CCEA M4 revision video. Please like the video, please subscribe to Corbettmaths, and just all the very best of luck with your studies. Good luck.